Hello, scientists. Today we're going to take a look at kinetic energy. So this is the same stuff we've been talking about before with the energy of motion, but this time we're going to put the math equation behind it. So I've pre-written some of this out. Let me just jump right in to the math equation. And once we really understand this, then we're going to do a quick practice problem also. So this is how we would most commonly write out the kinetic energy. We'll abbreviate KE for kinetic energy. And then the equation is that it is 1/2 times mass times velocity squared. So we would say it quickly, we'd say 1/2 mv squared. I just want to point something out that we're using a v there for the velocity. At this stage in the game, velocity is the same thing as speed. You'll learn in some future physics class that there's actually a little bit of a difference between the two things, but for us, go ahead and just treat those two words the same. Velocity is speed, speed is also velocity. But this is a square up here that we're going to need to do. So in your math classes, when you talk about what is the square of 4, that's where I would do 4 times 4 is equal to 16. So that's the same thing we're talking about there. All right, I could also write this out a little bit more fully. This time I chose to write the 1/2 out as 0.5. Remember, this is the same thing as the 1/2. So if I want to keep it all in one line, I'll say kinetic energy is 0.5 multiplied by mass multiplied by velocity squared. Remember, you have to do your PEMDAS when you're doing order of operations. And so once you know your velocity, I actually really need you to square it first. Then you can come back and take that number and you can multiply it by the mass and you can multiply it by the 0.5. Remember, these multiplications can be done in any order, but again, it's just the PEMDAS says first you got to do this square, then you can multiply those numbers together in any order after that. So just like with potential energy, we have some preferred units. This is really what we're after right now. We really need this to be in joules if we want to be able to compare how many joules of potential energy we have to joules of kinetic energy. And so in order to make this correctly come out in joules, your teachers have done a little pre-work for you, and we have to have our kilograms for mass, and we have to have meters per second for velocity. So it might seem a little funny that we have to be in these units, but it's just so that we actually get ourselves into joules over here at the end. So you may want to pause the video at some point and jot some of this down onto some slides. But this is the equation that we're going to be using for kinetic energy. All right, switching gears a little bit, let's look at this problem that I created. How much kinetic energy does a 850 gram bird have as it flies with a speed, notice I used a different word that time, but that's okay, a speed of 12 meters per second. So my equation is KE is equal to 1/2 mv squared, where speed is the v, because again, that's based on velocity, but they're the same thing for us. I gave this number to us in grams, so we're going to have to do a little work to convert that. And I know that we talked about how there's 1,000 grams and 1 kilogram, so I could write a conversion factor like this. Turns out that's not going to be a useful ratio for me. I need to use the flip side. So I'm going to flip it upside down and do 1,000 grams on the bottom. So let me come over here, 850 grams, and then I'm going to multiply this by the correct fraction that's going to cancel out grams. So we're doing math on the grams, and I need a gram in the numerator, that's that one. But I'm going to need a gram in the denominator. So this is the right conversion factor, not that one. Okay, so 1 kilogram over 1,000 grams. If I do this out, it's going to move the decimal place 3 times, and I'll end up with 0.85 kilograms. This number, my velocity or my speed, is already in the correct unit, so I can just pull that in. So kinetic energy is going to be equal to, I could either write 1/2 or 0.5 multiplied by 0.85 kilogram. I'm going to put parentheses around those just to keep it a little cleaner. Multiplied by 12 meters per second. And then I have to square that. And remember, PEMDAS says I have to do this first. So right down here, I'm going to do that. 12 times 12 is 144. This is going to look funny, and I need you to not worry about it too much, but I'm going to square the units also. So this is going to look different, but really I'm very interested in the 144 number. Okay. Then I can pull this down. So I didn't do anything. I just made sure I took care of the square first, and then I have 0.5. Okay. All right. Now this one's a little harder for me to do in my head, so I'm going to grab my calculator here. I'm going to go 0.5 times 0.85 times 144. So my final answer is that the kinetic energy of this bird is equal to 61.2, and I'm going to be able to call this joules now. So that's my final answer. Hopefully that made sense to you guys.